All right, so sanding, you asked for this topic, so we'll cover machine sanding. In the world of sanding, and I'm talking about body shops and detailers and anybody who's sanding on a car, there's different types of sanding, so we want to kind of focus on a certain type. All of these would represent, half a day trainings on each one of these. Mm-hmm. But the prep before painting, all that stuff, we're not going to focus on today. We're going to be specifically talking about just the top coat sanding. Mm-hmm. Although Rupes does have systems for all these other types of sanding. You see some of them on our display over there.
Is that the Scorpio stuff?
Scorpio and the dust extraction system, yeah. That's all body filler sanding, primer sanding, base coat sanding, all that. Mm-hmm. But clear coat sanding, totally different type of sanding. You can still use the Scorpio tools, but you're going to be using different abrasives, different products. So this is what we're focused on. And for detailers, from the detailer perspective, we're working on defects like this, a scuff mark, a scratch, acid rain etching or a bird dropping, this sort of stuff. Texture, sometimes texture is a defect that a car enthusiast wants out of their paint. It's rare, it doesn't happen a lot, but there are requests that come to detailers. Mm-hmm. Hey, I bought this brand new car, I don't like the texture, can you take that texture out and make it flat as glass? And that sometimes is a request of people. And also car enthusiasts, people have bought a high-end exotic car or whatever, and they have this kind of texture and they want to level it out. It's doable, but it's a procedure that one needs to be very careful about, because mm-hmm. you can remove a lot of paint removing that texture to something you have to be aware of. Also, defects like this. So this is layers and layers of car wash scratches and towel marks, and we call them love marks. Anytime you touch a car, you're probably scratching it. The normal approach from detailers or car enthusiasts is they would hammer this with an aggressive compound, an aggressive type pad, an aggressive technique, because it looks like a lot of defects, so they want to bring a big gun and mm-hmm. and mow that down. But the recent developments in technology on sanding products has allowed us to take this kind of defect and address it a completely different way. So rather than hammering it with a compound and perhaps a rotary, like you did yesterday, mm-hmm. Which would be the normal go-to for this kind of approach, we take a certain abrasive product that's new technology called a foam disc, and it will remove these defects without heat, without friction, I shouldn't say without friction, it has a little bit of friction, but without hammering the paint too hard, and actually without removing a lot of paint, and do it with a lot of control and no worries about burning through and all that stuff. So this sanding technology is, which we'll go out and play with this, but it's called a foam disc, and it removes defects like this in such a way that it's very cool to the paint and very efficient, and then you can quickly polish it with a random orbital system and be done. So what I'm talking about is an alternative to wool pad compound rotary. So reasons why we would do this sort of thing: well, faster defect removal than compounding, like I just mentioned. Removal of severe defects in the case of a spot repair. Leveling a texture, which there's lots of reasons to not do this. Mm-hmm. Yeah. So you want to be very careful when you do this texture leveling. And then runs and sags and dirt nibs, which those defects are mostly in a collision repair environment when they repainted the car. Those kinds of defects can be fixed, and the sanding process is one reason to do that. The type of sanding I'm talking about can be less aggressive than compounding, and we know this by electronic digital devices where you can actually measure film build, but also the surface roughness. It's called a digital profilometer. and it actually measures the topography of the paint. And if you hit a procedure like compound, wool pad, rotary, and compare that to foam disc technology, and then you look at the topography of the surface, you can discover that, hey, we didn't beat up the paint as much with this foam disc.
So let me ask you this. I mean, have you done, we talk about residue, like Kevin Brown method and residue control. And, obviously, the sanding residue is a huge deal. You're abrading the surface, creating residue. Has anybody actually microscopically, tested this of, taking a compound, making a pass, and then looking at the compound, looking at how much paint material is in there, or with sanding? Have you done any of that, or has anybody done any of that sort of research?
I'm not aware of a test like that, but it sounds like a good one to do.
I've been thinking about that a lot. I'm like, we talk about residue and we talk about the concept, and it seems it's like a scientific theory, right, that makes lots of sense. It's not a hypothesis, it's a tested theory.
Yeah.
But we could make it fact if we just, scientifically proved it.
Now, would you be thinking of a test like that to prove out the existence of the paint residue or prove out the impact of the residue?
I think it would mainly be impact. What does it do to the surface?
What does it do to the surface?
Right. What is the, because there are many camps that say, screw it, I'm not priming the pad, I'm just going to do it, and I get a result. And
I'm not going to clean the pad, I'm going to keep going.
And look, I just still get it, right? And then, of course, you physically can see it, right? Especially on a black car or a dark blue or something like that. You can see, hey, if I blow out the pad and do it, or if I don't blow out the pad and I do it, I have haze or I don't have haze, or I have tick marks or I don't have tick marks.
Yeah.
But man, wouldn't it be great? I think it'd be fascinating to make this a scientific fact, prove what, here is the residue, that's attached to the abrasive.
Yeah, I know we can see it because on a microfiber disc you can actually see the paint residue over time because it becomes a shiny glazed spot on the disc. So there's evidence that you can visually see it with the human eyes. You can also magnify and see it up close. But to measure the impact of it, I'm trying to think through the proper test. You could do gloss meters to show the loss of gloss.
But see, the freaking gloss meter is like a paint depth gauge. I put it here, I get one reading. I put it there, I have it in the same spot, I get another reading. I put it there, I get another reading, another reading. The accuracy of that seems so...
Well, it's accurate if you do that test properly. So there's a standard method for doing gloss, and you don't measure once.
Right, you measure and you take an average.
There's a cluster of 5, and it's a star pattern, and then you do the average in that spot.
But if I do that cluster again, then I get another reading.
Yeah. The other thing that's more accurate is a profilometer, that it measures physically the actual shape of the paint when you're done. So you can show the topography of the paint with a clean pad with no paint residue on it.
Right.
And then you can show right next to it what happens on the finish with a paint or a pad that has paint residue on it.
Right.
That test can be done.
Sure, yeah.
Now you got me thinking.
Call me when you do it. I want a video.
Because that would be a fun way to actually objectively prove the impact of what paint residue does.
Right. Prove the theory.
Yeah.
Make it a scientific fact.
Yeah. And it is evident. I mean, the result of a load of paint residue, you can see what happens on the paint over time, but I like where your head's going because it's a very objective and not a subjective way of looking at it. So.
Right. I mean, one of the difficulties of detailing in general is the subjectiveness of a lot of it, right? The subjectiveness of technique, the subjectiveness of the done result, for gosh sakes,
Yeah.
To one eye can look different than the next guy, And so I just love the idea of the more. I encounter this a lot in finance, right? The subjectiveness of what's the proper portfolio, what's the proper theory, modern portfolio theory.
I get this question a lot because I'm finding in the detail community, on the pro side anyway, not so much on the consumer side, but professionals are relying way too much lately on gloss meters. I get this question all the time, and the fact remains that you can have a good gloss rating, and visually to the human eyes, it can not look that good.
Right.
It's a fact. It happens over and over and over. So I'm a proponent personally, because I've done a lot of paint analysis, that I believe there's 5 devices that if you measured with all 5 devices, you will have the complete picture on paint condition. And if you isolate just one of the 5, you do not have the complete picture. You're talking about a fraction of the condition.
So that would be a depth gauge, gloss meter. The other one you just mentioned, what was that?
Profilometer.
Profilometer. What else is there?
Human eyes,
Right.
which is a very important
microscope?
one. No, that's not one of them, but I think that's a nice to have, but not necessary, because with the other devices you can get a...
Microscope would be for the scratch, I guess. You could assess that a little better.
So the gloss meter, depth gauge, profilometer, and then there's wavelength or haze meters that actually show texture and haze.
Well, some of the gloss meters will have a haze.
Yeah, they're kind of those 2 devices built into one.
Yeah.
You can get haze and gloss on one device. But then you should never, ever, ever rule out the human eyes, because the human eyes can pick up stuff that those devices
What's
can't.
your take on buying like a $125 depth gauge? I mean, are those...
I've gone full circle. So I started out in the beginning when I'm measuring paint. I got the lowest cost, cheapest one I could get, because at the time that's what I could afford.
So you had a stance. You don't need that expensive junk, right?
So I measured with those. And then the technology and gauges advanced, and now they have, you can measure up to 3 layers.
Right, on different substrates.
Yeah, on different
carbon fiber,
substrate,
plastic,
all this stuff. So I bought all those, and I played with all those. But I've come full circle, and lately I'm back to the $150 digital paint thickness gauge.
So then naturally everybody's question is, which one? What company? What model?
Well, actually, I'm going to show you the one I use, because it's unpictured. I think it's 2 slides from now. You'll see the exact one I use. And on the internet, I think it literally is $160. But if you look at the fine print on these paint gauges, the variance in accuracy will just blow your mind, because those $4,000 paint gauge that does all this fancy stuff, and then you read the fine print and you find there's a plus or minus degree of error of 6%. And I'm thinking 6% on a automotive clear coat, that's a huge variance.
Right, that's a half a pass.
Yeah.
Right. With a compound.
So, I mean, those devices are used in other industries where they're dealing with different coatings, and
right, they're looking at bridges and industrial integrity of I-beams and a skyscraper and stuff like that. Yeah.
So I don't even recommend those anymore, because the accuracy is not there for automotive paint yet. I think they'll get there, but the device is not there yet.
For me is, my GT3 RS has 3 different materials.
Yeah, you need 3 gauges, or
right.
Well, there's gauges that do ferrous metal and aluminum, and then there's another one that does composite.
Right, like the Positector 3000, the Delfesco. If you get because that's the other issue, is there's 7 different versions of that one model. You can order all the different packages to it. It's like, where do you draw the line? So I just say, screw it. I'm just going to wing it.
Well, Delfesco is one of those companies that is actually getting better about that diversity in the devices. So they have one base unit that you can hook up modules to. Right. And I like that concept, because then you don't have to buy all these devices, Right. So they've done a better job, I think, than any other brand of accommodating the differences. But all right, so this kind of blows detailers' minds when you say sanding could be less aggressive than compounding. But the fact remains that sanding with this technology that I'm about to talk about is less aggressive than compounding on the paint. So if we take a paint surface that is all scratched up like that previous picture I showed, just lots of layers and layers of scratches, you can take a surface like that, and when you compound it with a buffer and wool pad or whatever, you're going to make your passes and you're going to attack these peaks first, right? So you'll level those and you'll get down to this level where there's only valleys left. Now, if you want to completely remove this defect, you have to go all the way down to the deepest valley, right? So this is a lot of paint to remove that. But what happens with this foam disc technology is you take this defect and you convert it from this to a shallow, even defect that looks like this. And it's more of a controlled defect now. So to buff out this defect would be a lot easier and more efficient than this one. Because this actually, in some cases, will take 2 to 3 applications of compound to get down there. But when you convert the scratches to this, where it's a shallow, even defect, you're still removing paint to do it, but now you've converted the surface to something that is much more manageable, much easier to remove.
Well, because to get down there, you're heating up the surface, the paint is swelling,
So,
you don't have an accurate picture of where the, because 7, 8, 10, 20 days later, the paint settles.
Yes.
And then you see the valleys again, right?
And this approach doesn't heat up the paint, doesn't swell the paint. It doesn't introduce heat at all, in fact. So when you go to buff this out, you can actually switch to a foam pad and a polish in a lot of cases and remove that. So that's what we're talking about here. I was in Norway and there was an audience of, I think, 250 people, mix of detailers and car enthusiasts. And the question came, hey, Jason, what would you do to somebody new to car care, new to detailing? What would you teach them first?
Sand.
And I blew their minds away. I said, I would teach them wet sanding. And normally the thought when you say sanding, people think, oh my gosh, really aggressive, and I don't want to go there. I have to learn how to polish first. Well, the fact is that this technology I'm about to show you, this foam disc, is easy to learn, least aggressive on paint. It doesn't hurt the paint as much. It's a much better approach than hammering the car with a rotary. So, all right, so before you even sand, one needs to ask themselves a series of questions before you even start on the car. And you have to know the answers to these questions, because if you don't, you're going to get in trouble. You're going to do something to your car that you're going to regret if you don't answer these questions. So the first one is, what are you doing about texture? And the reason you need to ask this early on is because if the answer is yes, I want to remove texture, the orange peel, then you're going to head down a road with products and procedures that are going to remove texture. But if the answer is no, I don't want to remove texture, all I have is scratches, you're going to head down a different road with different products and different procedures. So you got to know that very early on. Because if you just grab sandpaper, put it on a machine and go, you may affect texture in a way that you don't want to. So
because you're affecting the texture of this spot, but then not that spot.
Yeah.
And
so let's say the goal was a scratch, an isolated scratch. What most people have done for years is they grab their hand sanding paper, scuff that area, scratch is gone, they buff it out, the sanding mark's gone. Beautiful spot.
But it doesn't match the surrounding.
But all around the rest of the door is texture. And many a detailer have actually gotten in trouble with consumers where cars come in for a spot repair on a scratch. The detailer successfully repaired the scratch, but now the customer's unhappy because they have a flat, shiny spot in the middle of their door and the rest has texture. So they're looking at this going, oh, that looks really good. Can you make the rest of my car look like that, And now they're in trouble. Because the detailer is going to charge $3,000 to do the texture removal on the whole car. So this is important. You need to ask yourself, what am I doing with texture? If the answer is no, do not remove texture, go straight to this foam disc technology I've been talking about. And the reason is because this foam disc will remove defects without removing texture.
Right.
Which is a beautiful thing for people that want to remove scratches without affecting texture. If the answer is yes, you need to ask another question. Do you want to remove all of the texture, or do you want to match the texture to an adjacent panel? Because those are two different things.
Mm-hmm.
And if you want to remove all the texture, it's a two-step sanding process, guaranteed, minimum two-step. You're going to use a technology called a film disc, which is a thin piece of paper, traditional approach to sanding. And that will remove texture.
Wet or dry?
Wet or dry. There's technology both ways.
Yeah.
It could have a wet product or a dry, or there's products that are wet or dry. Then you're going to follow up with the foam disc that we're talking about, which is going to refine that scratch and prepare it for a better buff out. So this is the case of, I want all texture gone. If you want to match texture to another door or another fender, then we're going to use a film disc also, because film is the only thing that will remove texture. Foam will not. So film is the only thing that will affect texture, but you're going to switch tools and you're going to switch the grit. So if we're matching texture, we're going to go to a lighter grit sandpaper, and we're going to go to a smaller orbit tool. And the reason that is because these orbital tools, the larger the orbit is, the more material it will remove.
So we're talking 2,000 instead of 1,500?
Exactly. Yeah. Or 2,500 or 3,000 in the here. And the grit or the orbit sizes, you're talking a 3 millimeter orbit versus a 9 millimeter orbit.
Right.
So something really large to remove a lot of material. Again, I tried to simplify this, but I think this is about as simple as I can get the message that you really need to ask yourself questions first.
We'll probably talk about this a little bit more, but one of, in spending a little bit of time with a block, in the little blocks, there's a certain set of artistic ability of, brain to hand.
Sure.
Am I thinking about this correctly? And there's maybe a little less of that hundreds and hundreds and hundreds of hours of honing that artistic ability with a block versus getting a machine. Is it easier to deal with?
It's a good question. So the comparisons between the two approaches, hand sanding and machine. Hand sanding will always, always, always be more accurate and actually, relatively speaking, more aggressive in terms of removing film build. So accuracy and aggressiveness can always be found with hand sanding. Machine sanding takes a bit of that out. It takes some of that accuracy out, and it takes some of the aggressiveness out, which is counterintuitive because people think, oh, I'm grabbing a machine, I'm going to be more powerful. And that's not the case on paint. Hand sanding applies more uneven pressure on the paint.
It occurs to me with the machine that you could easily dig an edge.
Yeah, you can get the edge cut. Edge cutting can lead to an uneven sanding mark, and the dreaded pigtail issues that everybody gets challenged with machines. That edge cut is you're asking for a pigtail when you do that. And I have a slide on that actually later. All right, so there is this discussion about electric versus pneumatic tools because both are used for sanding, and we like to talk about the differences. So we have electric tools, we have pneumatic tools. The pros and cons of each. So the pros on the electric side is you don't need an air compressor to run this, you plug it in. It's better suited for the mobile guys. This is a conversation for professional detailers. Can also be used for polishing. So you have this one tool that you can sand with, but you can also polish with. And they tend to have more torque. So in general, electric tools, the impact on the paint is more torque behind the pad compared to pneumatics. Now the downside is more torque.
Right.
So it can be a plus, but it can also work against you. So if torque is helping you to do an edge cut, then you're going to have more edge cut, and that's a problem. Obviously, the concern about electric tools with water, something about the physics of that doesn't go well. So you don't want to be standing in a puddle of water while you're using an electric tool. And also the weight and ergonomics. The electric tools tend to be heavier and bigger than pneumatics. So on the plus side of the pneumatics, better control of material removal because that extra torque from the electric tools can work against you, and the pneumatic tools have their torque drilled down a little bit. And lower maintenance, there's less moving parts in these tools, and they're just simply less involved with maintaining the tools. They're smaller, lighter. You can use one-handed, no problem. And there's also a lot more options on selecting an orbit. And this is very confusing for people because they don't understand orbits and the impact. But when you look at pneumatic tools, you have lots of choices on orbits. And ideally, in a perfect world, if you really wanted precise sanding, you would have an assortment of tools with different orbits to get the job done right. On the downside, you need a compressor, and sometimes, as you know, you did a lot of this research, sometimes you need a pretty powerful compressor. Usually the smaller the hand tool, the more of an air pig it is. So not so suitable for mobile use unless you plan on carrying that big compressor around with you. And these tend not to be very good at removing paint defects. Although they can be, they're just not as good as their electric sister because of that torque. Now, recently Rupes has launched that triple action tool, so that is an exception to this statement because we've put more torque into the air tool with that. And orbits, so the reason orbit makes a difference when you're sanding is there are small orbits. Small orbits are considered anything that's 9 millimeters or smaller. 10 millimeters or larger are considered large orbit polishers. Now in the sanding world, that scale shifts down because you're talking about 3 millimeter to 9 millimeter. So what a small orbit buys you is a reduction of material removal. So the smaller the orbit on the sander, the less paint that you're going to remove in per orbit. It's more precision and it's finer grit sanding. So when you get to those finer grits, it's actually better to drill it down to a finer orbit. Now the big orbits help you to remove material faster, which can help you in the case of removing lots of scratches or removing texture. So you want to grab your large orbit tool for that case. It also has this positive side effect of not loading as fast. So a small orbit tool goes around almost in place, and the paint residue loads up much faster because it doesn't have this longer distance to spread out paint residue. So the larger the orbit, the disc or the pad will actually stay cleaner longer. The load won't happen as fast. And it's more versatile, so you can actually take, if you had to choose between one, like let's say your budget, you only want one sander, then the choice should be a large orbit sander because it's simply more versatile. You can do a lot more with it. The smaller orbit sanders will limit your ability to do stuff. Make sense?
Yeah.
All right, so now we'll look at texture leveling. So this is the case on that decision tree where we said, yes, we want to remove texture. The reason we would want to remove texture is because it got repainted and it has a lot of texture, or it's a customer preference. So a show car or an exotic car or a high-end car that somebody wants more clarity and flatter paint, then that's a reason we would do this. So to do texture leveling, it's a two-step process at minimum. Now each one of these steps could be multiple steps, or it could, if you're doing it right, you should be able to do this in 2 steps. So you're going to pick a film disc, And this is probably starting at 1500 grit film. And that should, in most cases, with the right tool and the right technique, you should remove your texture. So texture's removed. You'll pick up your foam disc, which is going to be a 3000 grit foam product, completely different. So here's your film disc, thin, traditional sandpaper looking type product. Here's your foam disc. Now the abrasives are completely different. It's not a matter of, oh, we put foam on it and now we have this. The foam is not the big difference. The abrasive itself is the huge difference. Completely different abrasive technology and a foam backing. Now what this 3000 grit will do is it will take the marks from the 1500, refine them so that they're easier to buff out. If you skip this step, you're back to hard buffing because you're on a rough 1500 grit mark.
Removing more paint.
It could be wet or dry, as you talked about earlier. It depends on the brand and the product. Depends on what your preference is. There are some people prefer dry sanding because they can see what's happening on the paint better. If you're wet sanding, there's this wet slurry on the surface and you can't really see until you wipe it. They're both available in film disc. And this is where it gets a little confusing for people because now we're recommending that you put a foam interface in there. And that is different than the foam in the foam disc product. But this foam interface, the purpose is to, so here's a pneumatic sander. And the way human ergonomics work on this is even a very slight tilt of your wrist or any tilt of the sanding pad at all can result in an edge cut. Even, especially with a large orbit sander. The larger the orbit, the more even a slight tilt will do this to the paint. It'll start chopping at it. So that foam interface here, the purpose of that is to take some of that edge cut out and level it out. So it's impossible to keep this completely flat. But with that foam interface, even little slight minor tilts, it will remain flat on the paint surface, and that helps you to prevent pigtails.
I mean, how in the world are you going to get at a contour, like a curve, with a machine?
There's a great answer. There's technique to do it with that, but here's the better answer. The proper way, I should say the more effective, efficient way is to downsize your diameter. Mm-hmm. So you can use the same grit size, the same foam interface, the same orbit, maybe, and downsize your diameter to get into curves and contours. And that's the proper way to do it. The other way is people edge cut with this. If they're in a contour or they're trying to do an edge, they'll tilt the pad, and then you have a more aggressive scratch in that area.
That requires a little more skill with the machine.
Yeah.
Managing pressures and things like that.
Exactly. But the better answer is, hey, just downsize the tool, downsize the pad diameter, and you're good. Second step will be the 3000 grit foam disc. This is that new technology I'm talking to you about. You still use a foam interface, but now you have foam on foam. And this is the 3000 grit. And this will float over the surface, contour a lot better, and it will remove the aggressiveness of that 1500 grit sanding mark and mellow it out to the point where you can buff it out very easily. And that would be your second step. And if you've done this step properly, you can train your eyes to actually look through the 3000 grit sanding mark and see any remaining 1500 because they will look different. And when we get out there, I'll show you.
So would sanding, let's say, could it become as it becomes more common and more, as you educate the world on it, would you buy a new M3 and sand the whole thing with 3000 grit and then polish it?
There's lots of reasons not to do this, and you could do that if, let's say if the scenario was you're going to really buff it anyway, like if you're going to take a compound and even brand new cars can get defects from the car dealership. So
yeah, I mean my GT3 RS, I needed to compound the whole thing.
Yeah.
Or 90% of it, so I just did the whole thing. But it wasn't while I wasn't grinding away, I was using, I was using Jescar, a moderate compound.
Okay.
And with a microfiber cutting pad, because there were so many toweling marks and sanding marks, all kinds of stuff all over the thing.
Yeah. Now in that scenario, I don't think you should switch to this and call it a better approach. I think what you did was the better approach.
Yeah.
But when you are shifted into the decision of, I'm going to use a heavy grit compound, a heavy compounding pad, like a wool pad or microfiber. And
so, for instance, our Altima rental car out there.
Yeah. In that case, I would definitely do this.
Yeah.
And it would be better approach than hammering it with a compound and a machine another way. And we'll actually do that. We'll do that today. So if this is the second step after a film disc step, the amount of time and passes that you do should be multiplied times 2. So for example, if you're 1500 grit in an area, let's say you did 20 seconds of sanding in a certain area. With this step, you want to do 40 seconds. You want to double it, whatever it is. The biggest mistake people make with this refinement step is they don't do enough passes. And what's left is your 1500 grit remnant of a mark. You go to buff it out and 80% of the sanding mark comes out smooth, but then you have these little...
Now you got to go sand it again with 2000 grit or 2500, right?
For 3000.
Yeah.
So the important thing here is do it very thoroughly to completely remove the sanding mark from the previous step. All right, so that was leveling. Let's look at the scenario of what we call texture matching. And this is where you're trying to do a defect repair without taking all the texture out, but you want to take the peaks out.
I had this too, like on my previous GT3, they repainted the rear bumper and the texture was way off.
Yeah.
So here's the bumper and here's the neck, and so the bumper is a different texture.
Yeah.
So you don't want to knock all the texture out, but
some of it.
And the way I looked at it, I was like, well, screw it. I mean, they already repainted it, but if I screw it up, they'll just paint it again,
But that is the perfect scenario to what I'm talking about here, what you just described. So there's some texture, but you want to match it to an adjacent area. So we're matching the surrounding areas, what you're talking about. Another reason to do this approach is you don't have a lot of paint and you want to leave as much on as possible. Now, generally speaking, and I get this question a lot, how thick is the clear? Well, it's a variable from brand to brand of car. And the general rule of thumb, and it's a very general rule, and there's lots of caveats, but I usually say whatever the total thickness you're measuring, half of that you can assume is clear coat.
Not a third, a half?
A half. Because the base coat and the primer are very thin relative to a clear coat. The exception to that is if there's been a lot of detailing done to that car already, then your clear is thinner. But I would say half. Avoid high speed settings. So high speed on the air tools, high speed on the electric tools, that's not your friend for sanding because you can do what's called hydroplaning, where you're just spinning the disc on the surface and it's not biting. So medium speed to low speed on these sanders. If you're spraying water, avoid too much water because then you can hydroplane. And don't sand where you can't polish because guess what? You leave a sanding mark if you can't polish there, or you're rubbing it out by hand. So there are parts of a car that you definitely don't want to sand on. So if you're sitting there doing many, many passes, you're continuing to remove paint when you didn't need to. Because whatever it's going to do, it'll happen in the first 2 passes.
Wow.
So it's one of the biggest mistakes I see people do in sanding. They don't understand the difference between the foam disc technology and the film disc. The film is very rapid sanding. Literally 2 passes and you should stop and wipe and see what you got. Because most of the time, whatever you're trying to do, it will happen in those first 2 passes. There's a way that with the film disc you can get texture removed in the first couple of passes and don't remove more texture than what's necessary. In a lot of cases, if you remove 50% of the texture, not all of it, but half of it, it dramatically improves the visual effect of the paint. So in a lot of cases, the customer wants an improved result, but you don't have to remove all the paint to get a flat look on it. Pigtails, that's this defect here. And in this image, there's actually two different types of pigtails. And they're both caused by what's on that disc. So these load points is what's causing these pigtails. This load point around the edge, this causes that pigtail up there. See, it's a finer pigtail than this fat one down here. Those are two different size pigtails caused by these two different loads. And the load on a disc, as you can see, that's a 1500 grit film disc right there. The load is a variable, so it can happen fast, it can happen slow, it all is paint dependent. I've been on cars where 2 passes with the sander and the disc is loaded. And I've been on cars where you can do the whole fender and it's not loaded yet.
To unload, just blow it off?
You blow it with air. Or a cotton towel, not a microfiber. This is another big mistake, is people are wiping their sanding disc with a microfiber towel. Now microfiber grabs and holds things, including the abrasive on your disc. So it will wipe your paint residue off, but it will also wipe your abrasives off your sanding disc. So use a cotton towel if you're gonna clean it with a towel. Cotton won't grab it and rip your abrasive off. So, but I use compressed air, and I use the agitated compressed air from the tornado gun, and it cleans it one pass. But this is a big problem. And the other mistake I see people make is, like, I get these phone calls from detailers, and I'm sanding my car and I got pigtails all over the whole car. And I have to ask, I'm like,
why did you get that?
Why did you go to the whole car when you could see pigtails after the first application? So
that spot, right?
If you see that, this is preventable. And you should never ever have the case where there's pigtails on the whole car.
Right.
It should never be possible. So you should stop and fix this and then move on to the whole car. Now in this case, there's no foam interface, and that would have been the proper fix for this case, and cleaning the disc. If we're removing texture, the first thing we want to do is clean that paint. Now in your case, if you're not in a collision repair center, let's say you bought your car and it came in and you want to remove your texture or you want to fix scratches, you have no idea what's on that paint. It could have a paint coating, could have a polymer sealant, could have carnauba wax, could have polish, could have anything on that paint. So you want to strip this first using a stronger solution of IPA. Strip that paint, get residues and waxes off. Then here is the paint gauge. So that's the one I use now. X-Tech is the brand, and it literally is, I think, $160. But the accuracy, it's plus or minus 1%. So the most it could be off is 2%. What I use these for is not so much to be all crazy meticulous about measuring the paint on every panel. And there's some, I've seen the diagrams of people who measured their 5-star pattern.
Like a printout and
on every, personally I don't do that. And nothing against the guys that do, but this is, the functionality of this for me is, I'm going to measure a few spots on the car in the areas that I intend to sand. And I'm going to be asking myself, is this a go or no-go decision? And that's all this device helps me with. Because if I'm measuring 2 mils consistently everywhere, that's a no-go for me. I'm like, I'm not going to sand this. And not only am I not going to sand it, I'm not going to compound it. The most I would do is a very light polish with a foam pad and maybe wax it. But if I see something like 5, 6, 7 mils or more, I'm going to say, yeah, I can take a 1/2 mil to do what I'm about to do. That's all I use this device for. Then I'll pick up the film disc. We will remove the texture or the deeper defects, whatever the goal is. Here's a difference between what the film disc and the foam disc second step looks like. So this is refined. This is the 1500 by itself. And the second step will be switching disc to a foam disc, and that will be the 3000. So after the 3000 grit, you should see none of those scratches in there. And you should also begin to see gloss. You should start seeing gloss. And then you grab your compound, whatever your compound of choice is, whatever your pad of choice is. You do a test spot to dial that in on that particular car, whatever the good match is. And you buff out your sanding mark. And then optional second step, if you need it, is you'll take your polish and your polishing pad and you'll do that optional second polishing step. Then if you like, if you want, you can measure again. If you're new to sanding, it's good to do this before and after measurement, just so you can begin to learn how much you're removing. One recommendation is if you're going to do this post sanding measurement, let the paint cool for at least several hours before you measure this so that everything can begin to settle down before you measure. Because if you did it immediately after buffing, there's the potential that you're measuring swollen paint.
Okay. So you might measure more than what you started with.
Exactly, yeah. Wow, I grew the paint.
You flowed it.
Then you'll want to strip again, take out the residues, and really look at the paint, make sure you've got all the sanding marks and all the buffer trails and all that stuff out. This kind of sanding can be done with the Rupes Duetto, and the Duetto is actually a tool with the intention of being a sander and a polisher. So if somebody wanted to just get one tool to do both sanding and polishing, this would be the recommendation.
Because of the balance, the way that it's set up?
Well, they backed off on the torque, and they adjusted the whole tool for sanding. So the one limitation of this, however, is that the backing plate size is tuned for this tool is 5-inch. And 5-inch sanding products are limited on the market. They're hard to find. They do exist, but most sanding discs are this size, which is your 6-inch.
So you could just put a 6-inch pad on there, couldn't you?
Oh, you could, but you would throw off the balancing of the tool. But yeah, you could. All right, and then the other option is to take a full-size Bigfoot electric tool and sand with it. And in our advanced training classes, we do exactly that. You can take a Bigfoot 21 millimeter or 15 millimeter and throw a foam interface pad and throw a foam disc on there and sand with it. Now the difference is the sanding pattern will look different, and people make a false assumption that compared to this, if I take a full-size electric polisher and sand with it, I'm going to be more aggressive. And that's not necessarily the case. So remember, a large orbit doesn't mean more aggressive, it just means a different path that abrasive is going. So the sanding mark visually will look different. This 6 millimeter orbit sanding mark versus a 21 millimeter, the sanding mark's going to look very different. The depth of the sanding mark is 100% dictated by the grit of the sandpaper, not the orbit size. So the depth of the sanding mark is the sandpaper. The amount of material, the material removal rate, is dictated by the orbit.
So does that require a different type of paper? Like, will a 21 beat up paper differently than
it will definitely abuse sandpaper more than that.
Yeah.
So you'll find yourself switching discs more.
And sanding discs aren't cheap.
No. So you'd only want to do this if you really had to. If you have this tool, there's no reason to go to that.
I would also think, and we'll go out there, but I would think that this would be easier to maintain flat pad
It definitely is.
than a big old machine.
Yeah. But the reason I mention this is we get this question a lot. Can I sand with my Bigfoot
Right.
21?
You're
And
in
the
a
answer,
pinch.
the
Right.
answer is yes, but you got to understand what you're doing. All right. That's that.
Because what happens when the force pulls you back, your foot naturally comes off the gas. You have to keep your foot to the floor, foot to the floor.